Welcome to CareData Portal, a clinical government platform for Australian residential aged care. Here's the team making it.
Hi everyone, my name is Sungwin and I'm the team leader of the CareData Portal project. My responsibility include helping team members work together, managing tasks and project progress, supporting technical work, and making sure all parts of the system work smoothly together as healthcare analytics platform.
Hello, my name is Wayne, software engineer building CareData, a browser software as a service to automate reporting with one-click separate values upload.
Hi, I'm Nelly. I'm the technical leader of this project. I build across Frontend, Backend, and Azure Cloud. I own the voice biomarker pipeline and the testing setup.
Hi everyone, my name is Hazza Al-Hashmi and I'm the software developer of my team. I'm responsible for implementing the coding tasks, prepare testing specifications, and performing integration testing to ensure the system works correctly.
Hi, I'm Ming, a software engineer of CareData Portal with a focus on front-end development. I build React page and reusable component, implement data visualization, and craft user-facing flow. Hope you guys will enjoy our application.
Aged care facilities still submit quarterly quality indicator data via fragile spreadsheets and 13-section GPMS paper forms, requiring manual cross-referencing that leads to broken formulas. Missed deadline and director of nursing spend hours on data entry instead of care. Primary users, directions of nursing, quality managers, and ACQSC auditors benefit from CareData 3 core advantages. Dashboard analytics across 14 AISWQI categories, one-click CSV upload with built-in validation, and government format reporting from any browser. The Marketing 7-page product web-based clinical government platform. The price SaaS subscription, facility volume pricing, the place cloud-hosted browser native no install. Promotion, AIHW alliance positioning and peer benchmarking. People, clinical governance specialists. Process one upload, automated indicators. Physical evidence, GPMS, format PDF report.
Now we move from the product story into how CareData is built. The next section shows the actual system architecture, the React frontend, the FastAPI backend, Azure storage, and the fallback paths that keep local environment reliable. CareData is split into 4 clear layers. The React and Vite client renders user-facing pages, the FastAPI backend owns authentication, indicator and voice analysis, the domain services turn data into structured results, and the persistent layer stores record in Azure tables and voice audio in Azure blob storage. When Azure configuration is missing, falls back to in-memory storage for demos and tests.
Blogs, tasks are first assigned in Jira. Team members develop their features and push the code to GitHub. Then me or Natalie will review the code to pull the request before accepting and merging it into main branch. After the merge, GitHub Actions automatically start the CI/CD pipeline. If the update is for the frontend, it is automatically deployed to Azure static web app. If it is for backend, it is deployed to our web app service called CareData API. Both services are connected to our production domain caredataportal.com. Finally, the team performs testing on the final deployed product to ensure all the features work correctly before release.
With the architecture in place, we can now work through the live system. We begin on the CareData landing page. The product message is aimed at aged care quality teams. The user signs in through Google Authentication. After authentication, the frontend receives the session token and moves into the protected application routes. From this point onward, API requests are made as an authenticated user. In data entry, the workflow supports manual entry and CSV upload with validation. The QI form mirrors the government reporting structure, so fields entered respect the government format. As you can see over here, all fields support GPMS form. The export tools support downloading the official template or export manually entered data. The dashboard turns uploaded or entered record into visual review screens. Users see indicator trends, category panels, and risk movement over time. The dashboard also supports drill-down views. The facility can inspect indicator category by category, compare current and previous quarters, and see the performance was improving or worsening. With the trend analysis tab, this information becomes even clearer. The voice screening page shows the second workflow. Nurses can review residents, baseline status, concern score, or open alerts. This is designed as monitoring tool support between quarterly reporting windows. The report sections provide per indicator detail. Each report combines the indicator definition, aggregated quarter data, resident level detail, and exportable government detail. Benchmarking tells the exact position where facility stands compared to national benchmark. Once logged out, the user is turned to public landing page as an unauthenticated guest. Now we move from using the application to reading the implementation. The route table reads as a single design statement. All workflows wrapped in require auth. The bearer token writes in local storage, attached to every request. The resident recording route is deliberately public. The signed token in the URL is the credential. Require auth is just 6 lines. A token check, a redirect on miss, children on hit. The door decides. Everything past it is rendering. .py establishes the surface. A course list pins the production domains, plus the regex for any new Azure static web app deploy. JWT-auth.py holds the staff gate. One bearer dependency verifies the JWT signature, its expiry, and the subject claim. A signed URL token checks for 3 failure modes: missing, consumed, expired before any audio is read. 2 paths, 1 file decides who can pass. For staff, a JWT bearer is verified. The CSV is shape-checked. Quarter labels passed. 14 keyword indicator computed server-side persisted by user. Adjacent envelope returns. For residents, the URL token is checked for state. Pydantic validates the body. Browser autogain is rejected in code. Audio splits into 4-stage battery. A vector scores against the resident baseline. The alert returns. The React client receives JSON. It never recalculates an indicator. It never makes a clinical decision.
CareData Portal saves HK staff hour every quarter. No more manual spreadsheet, no more re-entering data into government forms. The voice biomarker model fills the 90-day gap between quarterly checks, catching early signs of decline before they become critical. Looking forward, we plan predictive QI modeling, real-time voice alert, and multi-model risk scoring, moving from reactive reporting to proactive care.